All right, what shape is this? Who can tell me? Hands raised. Go ahead, Ms. Glenn. It's a parallelogram. Who can tell me why? Parallelogram. Yes, ma'am?
Because it has two sets of parallel sides.
It has two sets of parallel sides. Remember, this symbol right here means parallel. You can just use // in your computer. Two sets of parallel sides. How else? I mean, what else do we know about it? Yes, ma'am.
It has two sets of congruent.
Has two sets of congruent sides. Okay, two sets of congruent sides. Good. Now, did we do the distance formula and actually calculate these side lengths? But in order to definitely say that, we would need to do that. But that's not the point of the lesson today. Just keep in the back of your mind, if you're going to make this statement, you're going to have to back it up with the distance formula. Good thinking. What else do we know about this? Anybody know where? Yes, sir?
A, B, and B, A, B, and B, C.
AB and BC, he says, are parallel. Oh man, I put the congruent symbol. I anticipated wrong. My bad. How do I show that they're parallel? Anybody? The arrows, right? So I'm going to do an arrow here, an arrow here. Can I put one arrow on AB and DC? Why do I need to put two? Okay, so these two go together, but this one is different, so I need to put the same number on DC and AB. Can you think of anywhere in real life where we have parallelograms?
Highway.
Okay, a highway on a map. Sides. The state of Kentucky kind of, or Tennessee kind of looks like a parallelogram to me. I don't know.
The computer.
The computer. Oh, you're talking about, can I borrow this, like the tilt of the angle? I thought about that, the screen tilting. Okay. That's parallel. All right, gentleman in the back, come back, please. Hey, I won't call you out. Come back for me. All right. So, what we're going to talk about today, we're going to work on half of this standard. Oops, you close my ink glare. Half of this standard. We are going to prove the slope criteria. We're going to talk about what that slope criteria, the meaning is for parallel and perpendicular lines. And we're going to use that to say things about geometric shapes. If I say it's a parallelogram, I have to back it up by proving that those lines are parallel. All right. Go to, actually, that is the last slide in your slides, correct? If you would, please, go ahead and put screens down. We're going to take some guided notes. I filled in most of it. You're just going to type them in. We'll come back to our closure on your slides here in a little bit. So if you would take one pass back. Take one pass back. Anybody not get a sheet? Take one pass back. They're coming on your side. Sheets and glass or do something. Listen up, eyes and ears up front, please. Thank you. I have done 90% of the work here. You just have to fill in a couple blanks, okay? So we're going to look at these. First off, does this look like on here, does this look like the first box on your notes?
Yes.
All right. What do these parallel lines have in common? But how do you know?
Same slope.
What do you mean, same slope?
Same slope, different line.
Okay, so hold on. What is the slope? How do I get the slope? I have to count that rise over run. So if you would, everybody, what's the y-intercept on the top line? 1. Okay, draw a point on 1, and let's count the rise over run. Is the rise up and down or left and right? Up and down. We want to go, how far? I'm going to make these 2 points. I need to see how far up and how far over to go. Devontae, if I start at 1, how far up do I have to go to get to the next? I have to go up 1 and then right 2. So that's up 1, right 2. So what's my slope? What was it? We went up 1 and over 2. So my slope is 1/2. Jennings?
I thought that the slope was always 1/2, not half.
Okay, it's 1/2, right? All right, Dillard, what's our y-intercept on the second blue line? -3, good. And I want to come and find the next lattice point. What's my slope? How far up and over do I go?
1/2.
Of 1 over 2. So the slope for this line is 1 over 2. Was Mr. Johnson correct in his assumption? What did he say parallel lines have? The same slope. So on your paper, we need to fill in what blank? What do we fill in? What slope?
Same.
Good. So, notice here, parallel lines, you're going to fill in, have the same slope. Right, same in that first blank, please. Parallel lines have the same slope. To prove it, what did we do? We counted the rise over the run. Now wait, mine doesn't spell this correctly. Why? Why did I do it this way? Show Miss Glenn.
Rise, Y,
Good. The rise is the up and down. Good.
and the right is
Which is left and right. Good. So notice the x-axis is the horizontal left and right. Rise and up and down. Left, up, and down is the y-axis. I clearly know how to spell these words, but I put it this way so you can remember it's the change in y, up and down, over the change in x. That is the slope. Does that make sense? In the slope-intercept equation, where is the slope? What variable is the slope represented by? Yes, ma'am? Just the M, right? Mountains. Why do you think I put this picture here? Because mountains have slope, the steepness, right? If you go up the mountain, that's a positive slope. If you're hiking back down, that's a negative slope. Okay? So, parallel lines, everybody has what slope? Same slope. Let's try this again. Parallel lines have same slope. So, if I give you, that's what shape we're going to go back to.
parallel.
If I give you that opener, if we go back to this here, you told me it was a parallelogram. How can I prove that the opposite sides are parallel? I have to count the
Slope.
and the slope should be the same. So let's find the slope for AD.
Wait, something right in parallel.
Right in parallelogram, right? It is a parallelogram. So what shape is this? We already know it's a parallelogram. Parallelogram. I have a hard time spelling. All right. Now, let's find the slope of AD. If I start at A, how far up or down? Do I go up or down to get to D? I got to go down. Randall, there's a fill in the blank notes up here. If you'll grab one. We got to go down. 1, 2, 3, 4, 5, 6, 7. So we went down 7. Is it positive or negative if we go down? So -7. And how far over do we go? 1, 2, over 3. Right now, all laptops should be put away. You don't need those right now. Our slope was -7 over 3. What will the slope of BC have to be in order for these to be parallel?
-7 over
It's got to be the same, right? So let's check it out. If we start at B, you see, count the spaces. How many do you have to go? Are we going to have to go down again?
Yes.
Yeah, and we're going to have to go over. Count it and see if it's -7 and write 3. What'd you get?
I didn't
Now, BC is -7 over 3. So what can we say about AB and BC? They're parallel. More importantly, how do I mark that on my parallelogram? The arrows. What does the tick marks mean? Because that's a common answer. Congruent. We didn't do the distance formula. We haven't proven that with the distance formula, so we can't put it on there. We can, however, put an arrow here and an arrow here. Why can I say they're parallel? They have the same slope. And I even gave the slopes to back it up. Does that make sense? So what is the slope of AB?
Next slope.
Let's check her out. She says go down 2, so it's -2, and over, and we went over 4, -2 over 4. Is that the same for DC? Let's check it out. Go down 1, 2, right? 1, 2, 3, 4. So this is -2 over 4 as a slope. DC is -2 over 4 as a slope. What can I say about those two sides?
They're parallel.
Why are they parallel, everybody?
Because they have the same slope.
Same slope. If you count the rise, meaning up or down, and the run, and they're the same, you can always say they're parallel. How do I show they're parallel? The arrows. I'm going to give this one 2 and this one 2 to say that the 2 arrows mean those sides are parallel. Miss Jennings.
Okay, you see how the slope is next to one?
Yes, ma'am?
If you simplify it and put -1 up, it'll be wrong.
Well, here's the question. Is -2 over 4 equal to -1 over 2? If I divide 2 out of the top and 2 out of the bottom,
Yes.
those are equivalent. Here's the danger, though. Yes, these are the same. If I put -2 over 4 for BC, and I put -1/2 down here, will everybody recognize that those are the same necessarily? No. If you simplify both and you put -1/2 and -1/2, that's fine. I would just be careful to make sure you do both of them. Simplify. Otherwise, you might leave one as -2 over 4 and the other one as -1/2, and be like, those aren't parallel, when in fact they are. You just have to simplify.
Okay.
Yes. Okay? Right now, if I asked you about parallel lines, you would tell me, how do you prove it?
Wait, find the slope.
By the slope. But what has to be true about the slope?
They have to be the same.
Has to be the same. Was that really hard? Now, we talked about parallel lines. What else? What other kind of line do we need to figure out the pattern for? What else besides parallel? We got parallel lines and we got perpendicular. Let's check out some perpendicular lineage. In your blank, we would need to fill out the slope. So the slope of AB was -7 over 3. BC, oh, I see what you're saying, Lindsay. My bad. Let's go back. At the bottom of your guided notes, we should write AD is parallel to what? BC. Make sure you put the segment line on top to show that those are segments. What else can I say? What other statement do I need to fill in to the right? AB to DC. Good. That's not Washington, D.C. That's the sign of the parallelogram. Don't be confused. Okay, as long as you prefer that, I just want to make sure. Alright, let's rock and roll to the next page. What type of lines are these?
Perpendicular.
They're perpendicular. They intersect. Pause real quick. They intersect at what kind of angle? A right angle, which is how many degrees?
90.
Okay, so these are intersecting at 90 degrees, but I need to figure out the pattern. All perpendicular lines have something with the slope. So let's figure out the slope. Let's look at this line right here. Is the slope going to be positive or negative? Negative. Why negative, Marquez? You're right. Because it's going down from left to right, right? I'm going to pick two, what they call lattice points, where it's easy to read on the graph. I pick these 2 points. So if I start here, I need to go down 1, so I know the slope is going to be -1, and then how far over? So right 2. So the slope of the red line is -1/2. We found the slope of the red line, correct? It was -1/2. Let's find the slope now of this one. I need to pick 2 lattice points. I'm going to pick this one right here. It's clearly at a lattice point. And I'm going to pick that y-intercept as well. How far up do I have to go? 1, 2, up 2, and to the right, 1 space. Oh, she says it's upside down. What's another word for upside down?
Reciprocal.
Oh, what?
Reciprocal.
Okay, so now wait. It is the reciprocal, but okay, first off, I've got 3 people who remember the vocab word reciprocal, but what does reciprocal mean?
You really know.
Okay, so
But then again, that one.
reciprocal. The reciprocal of 2 over 5, just flip it, is 5 over 2. So you just flip it. Now, Miss Jenny says there's a difference though, because it was originally negative, and now it becomes positive. So, the rule for perpendicular lines, it is the reciprocal, but what about the signs?
They change.
What's it called when you do something differently? It's the opposite reciprocal. So on your paper, you should have 2 blanks to fill in. I'm so glad that you're so proud. Now, right here, fill these in. Boyd, Dillard. Okay, good deal. We have opposite reciprocal slopes. Okay? How do you prove that 2 lines are perpendicular? The same way you do it with parallel. You're going to count the slope, the rise over run, and you're going to see if it's opposite reciprocal. If it's not, they're not perpendicular. If the fractions flip and one's positive, one's negative, they're opposite sides, those are perpendicular lines. This is the symbol to show a right angle. So on your work period, when you're finding the slopes of 2 lines and you find that the slopes are what when they're perpendicular?
Right.
What are the slopes of perpendicular lines? Opposite reciprocals. The way you show that is by putting a square in the angle. This is the right angle symbol. That means they are perpendicular. They meet at 90 degrees. Does that make sense? So to show that they're right angles, draw that little box right there, okay? Questions about perpendicular lines? All right, you ready? Okay, go ahead, Ms. Back. If the slopes are opposite reciprocal, your lines are perpendicular, you put the box. If the slopes are the same, then the lines are parallel. And how do you show they're parallel? The arrows. You marked it with arrows. Very good in the back. All right, so let's check out one last example here. What shape is this?
Isosceles triangle.
It might be, but are we worried about the distance? Why is it not isosceles? Talk me through it.
They not all of them. I mean, they all different sizes.
2 of them are not the same. This distance is longer. It is a scaling triangle, but there's actually an important kind of angle in here.
A right angle. 45.
There might be a right angle. It might be 45. Let's check it out.
It is a right.
Let's find the slope.
Yes, it is. Yes, it is.
Here we go. AB. Wait, now just a few. AB, what's the slope of AB? How do I find the slope? Count the rise over run. Right now, take a minute, find the slope of AB. Anybody agree with me?
Yes.
I'm not sure that mine's right. Don't disagree for the sake of agreeing. I counted down 1, 2, 3, 4, 5, and right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. All right, so we got the slope of AB. Find the slope of CA. Gotta go up 1, 2, 3, 4. So positive 4 over 1, 2. Anybody get 4 over 6?
Yeah.
Me?
I said negative.
Your lines are blurry. I apologize. I'm sorry. That's why you've got this graphic up here. Sorry about that. Last but not least, find the slope of BC.
Negative.
Now, if you didn't get these, jot these down. Okay. What lines might be perpendicular? Which angle looks like it might be a right angle?
B.
This one right here, right? That one's too small. That one, maybe. But we're checking this one out right here. So we're looking at BC and CA. CA and CB, okay? So what can negative 9 over 6 simplify to? What can I divide out of both?
3.
3. What is negative 9 divided by 3?
Negative 3 over.
Negative 3 over 2. What can I divide out of negative or 4 and 6? What is 4 divided by 2? 6 divided by 2. What do you notice here? Are they reciprocal? Are they opposite signs? What can I say about these two sides then? Perpendicular. And so they meet at a right angle. Last but not least.
What was the plate?
So what kind of triangle is this? It's a right triangle. And at the very bottom, was there anything else to solve it? Prove it with the slopes. What was the slope when we simplified CA? 4 we simplified it. 2 over, and this was negative 3 over 2. This proves that it is perpendicular because they're opposite reciprocal. Okay? You need another second, or are we okay here? Okay? So far, does it make sense? Parallel lines, they're the same steepness, so their slope is the same. Perpendicular lines, they meet at 90 degrees, and their slopes are opposites, one positive, one negative, and then the fraction flips. They're the reciprocal. Okay? Last but not least, horizontal and vertical lines are always what? Crossing perpendicular. They are always perpendicular. Fill that in, please. I want you to think about this. Has anybody ever gone snow skiing?
Yes.
I've been snow skiing only twice in my life. Okay? So, there's some snow skiing. You do it in the mountains, right? If you are snow skiing down a hill, the slope is negative, you're going real fast, right? If you're snow skiing up a hill, it's a lot harder, right? Can you snow ski on a horizontal line?
Yes.
No.
It's called cross-country skiing, and if you have ever done it, it is the most difficult. Focus, please. Snow skiing is an Olympic event. I can show you a YouTube video. Cross-country snow skiing. They're just going on flat ground. It's all in the arms. It is the most exhausting thing ever. It is terrible. If the ground is flat, is there any slope? No. Horizontal lines is 0 slope. Now, if you went skiing down a vertical line, if you go skiing down a vertical line, that's not called skiing, that's called falling. Now you cannot ski. You can't. So the slope is called undefined. You can't ski down a straight line or ski up a straight line. It's called falling. So there is no slope. You can only ski up a slope or down a slope if it's positive, negative, or flat. If it's vertical, you're just falling. There is no skiing. There's no undefined slope. But we're talking about skiing. Remember, mountains have slope. We're skiing here. All right. Questions? All right, real quick. I'm going to do a little bit of popcorn. I'm going to call on random people. Every answer to the questions I'm about to ask you is on your notes. So I'm going to ask the question. Do not call out. I will call on somebody after I give you 3 seconds to look on your notes. Okay? Probably give you class points. Question number 1. Perpendicular lines have what type of slope? Think for 3, 2, 1. Kathleen, perpendicular lines have reciprocal, and what other word, Manir? Blank reciprocal. What kind? Opposite reciprocal. Good. Parallel lines have blank kinds of slope. Kivante, parallel lines have same slope. Exactly. Great. All right. Parallel and perpendicular, horizontal and vertical lines are always blank. Think for 3, 2, 1. Vertical and horizontal lines are always perpendicular. If you can remember those 3 things, you're going to be really successful today. For your work period, you have 4 corners. You and a friend are going to work on this together. All you have to do on this is prove to me that the sides are parallel by telling me what? The slopes, and then draw the arrows. Also prove to me any perpendicular lines. How? How do you prove perpendicular lines? Opposite reciprocal slopes. So I need to see the slope for every segment here, and then if they're parallel, draw the arrows. If they're perpendicular, draw the right angle box. Questions on your work period?
That was the best. I had a